Yes, guys. So we are doing seventh question, which I have completed, but there was some problem here, some calculation mistake. Now I have let me revise this. Answer is now this is the last answer, and this is the correct one. So let me just revise this. How I have to remind you this. Required area of the loop of the curve, which is given here, limit theta 0 to pi by 2 within the limits or within the range, theta equal to 0 to theta equal to pi by 2. Okay, this question was to be calculated, and the curve was r equal to a theta into cos theta, a theta into cos theta. So we just put the area of a polar curve that we know what is the area, half within limits alpha to beta. Here alpha is 0 and beta is pi by 2, and r square d theta. Now value of r square is a square theta is square into cos square theta. Now we have taken 1.2 a square out of the bracket. Sorry, this one 1.2 a square out of the sum of integration 0 to pi by 2. So theta, now cos square theta is 1 plus cos 2 theta upon 2. We have changed it to d theta. Why? Because cos 2 theta we know about 2 cos square theta minus 1 from trigonometric identity. This we have used here. Therefore, 2 cos square theta equal to 1 plus cos 2 theta, or cos square theta equal to 1 plus cos 2 theta upon 2. Simple. Up to this point, now this theta square into 1 upon 2, this theta square upon 2 are taken to 1.2 out of the sign of integration. So this is 1.4 here, 1.4 a square now. Okay, then remaining value 0 to pi by 2 is theta square d theta. I have separated this. Now theta square into cos 2 theta, this one, theta square into cos 2 theta, this I have separated second integral as. Okay, now this is to be integrated by parts. So integrating this by parts, integrating it on integration by parts. So we get here, what do we get here? This is 1.48 theta square is theta q by 3, limit 0 to pi by 2. Okay, we have substituted here plus sign. Now this is in by parts method. Theta square as it is, cos 2 theta integration is sin 2 theta upon 2, positive value, limit 0 to pi by 2. And here theta square is minus sign, theta square is differentiated, so this is 2 theta into cos 2 theta integrated sin 2 theta upon 2, this 2 and 2 cancelled out. So left over value is theta into sin 2 theta d theta. This is again integrated by parts. So this again integrating by parts. So we get here, now putting the limits in this case 0 to pi by 2. So in pi by 2, if I put the limits theta in place of theta, this is pi by 2 whole cube, that means pi q by 8, 3 at 24. This is pi q upon 24 plus, okay, at lower limit this will be 0, this 0. Now in this case, okay, so this is 0 here because pi by 2 sin 2 theta, sin 2 into pi by 2 means sin pi is 0. At 0 it is 0. So in both the cases it is 0. Okay, so this value is 0 I have taken with minus sign here. Integrating it by parts, so theta as it is, sin 2 theta integrated as minus cos 2 theta upon 2, limits 0 to pi by 2. Now minus sign is in between, and in between minus sign is also again done. So this is minus minus plus here, and this minus sign I have taken out of the sign here. So this minus and this minus is not because of this plus. Minus sign is there, but from inside minus cos 2 theta, this minus sign I have taken outside, so this is plus sign. Okay, or we can say that after applying this minus sign, there will be 3 minus signs. In between we put minus sign. From this minus cos 2 theta upon 2, minus sign will come, and this minus sign, so it will be with negative sign here. Okay, but after this integration, this is 0 to pi by 2. If I put at pi by 2, this is pi cos pi. Okay, because cos pi is minus 1, this is minus sign here, so plus 1, but this is minus sign. it is -1 here, but this pi by 2 in place of theta is pi by 2 into -1. This is pi by 2 into this 1/2 into -1. This value, and this is 1.4 a square are multiplied inside. 1.4 a square multiplying to this is giving this one. Okay, at 0 it will be 0 because theta into something, and at place of theta if we substitute 0, at 0 it will be 0. So minus sign, there are triple minus sign, minus sign, minus sign, and this minus sign, sorry, this is minus sign here. This is for this minus sign, and this plus sign is minus sign here. So okay, again I have to integrate this. Okay, sorry, this is with minus sign, it is 0 here. For lower limit we put at 0, it will be 0 here, because minus, minus and triple minus, because when you substitute the lower limit, then triple minus sign is coming, so it is -0, because it's theta into something, so 0. This is up to this point. Now this integrated cos 2 theta is sin 2 theta upon 2 again, so it is 4, and 1.4 a square is coming from beginning, so 1.4 a square that, and sin 2 theta upon 4 is this value. At limits 0 to pi by 2, what about this sin 2 theta? If I put theta pi by 2, it will be sin pi is 0. At 0 it is 0. This is 0 in both the cases. This value is 0. Only this and the first step, which is 1.4 a square pi q upon 24. Okay, this is pi q into a square upon 96, and this value is 4 4 is 16 a square minus sign minus pi a square upon 16. These two are to be added up. So from this we have to subtract pi a square upon 16. So this we have obtained, taking common pi common, a square common. So if I take pi a square common, 96. Okay, now 16 6 is 96, so this is 6 here. And this is, so pi square minus 6 is in the bracket, and pi a square upon 96 we have taken common. Okay, so pi a square upon 96 we have taken common, and this is pi square minus 6. This is the final answer. Question 7th is done in this way. Okay, so this I just repeated so that we can understand the simple question. By parts we have to just apply, but before that I change this cos square theta into, so this has become easier then. Otherwise that could be done with the help of cos square theta also, but there in that case we have to apply the reduction formula. That reduction formula was creating some mistakes, so I have just left that, and I have done this with the help of changing this cos square theta as this one to cos 2 theta upon 2, which is simpler answer. Now let me take question number 8. What does question number 8 say? Let me check. Okay, so question number 8 is of what kind? Let me check. Okay, so after this question 8, the 8th question is of what kind? Let me see that. Okay, so question number 8. Question number 8, what does it say? Which question? Now question 8 says that find the area bounded by the equiangular spiral. This is equiangular spiral r equal to a, e, and theta, and the radii vectors theta equal to alpha to theta equal to beta. Okay, so these are the given to us. How many limits are given to us? Within this limit we have to find out the area. What is the area of? We know that required area, but before that let me write the curve here. The curve, which is equiangular spiral, r equal to a, e raised power m theta. This is, and limits are okay, or within the range, within the radii, and the radii vectors are, theta equal to 0, theta equal to pi by 2. This is alpha and beta. So these are the alpha and beta. So in terms of theta equal to alpha, theta equal to beta. Okay, so these are unknown numbers. No problem. Within these two unknown numbers, the range, we have to find out the area of this curve. So here, no need of drawing the curve because the limits are given here. Okay, so required area of the equiangular spiral is equal to, we know that this is 1.2, the limits are alpha to beta r square into d theta. This is 1.2 alpha to beta. R square is here, a square is squaring this, e raised power twice m theta into d theta. Okay, so we have just squared this, a e raised power m theta, so this is a square into e raised power twice m theta. Simple. Okay, so integration of this is, let me take 1.2 a square out of sign of integration, this is alpha to beta e raised power twice m theta d theta. So integration of this will be 1.2 a square. Okay, e raised power, this is twice m theta, constant is twice m dividing by twice m, limits, sorry, alpha to, and the limits given to us are alpha to beta. Now putting the limits here, 1.2 a square, which is common or out of the bracket, this is, or upon twice m is also common here, so let me take twice m out of this bracket. This is e raised power 2m into beta minus sign e raised power 2m into alpha, or this is a square upon 4m into e raised power twice beta m, or m beta doesn't matter, minus e raised power twice alpha m. Okay, so this is the final answer. This is in terms of alpha and beta. A square upon 4m, this 2 into 2, 4m into e raised power twice m beta, or twice beta m, minus e raised power twice alpha m, or twice m alpha. Simple. This is the answer here. Finally, this is the answer of question number 8. So no need of drawing the curve here. Just we have calculated the answer. So this is, everything was given here. The limits were given, radii vectors were given, and the curve. Just we apply the formula for polar curves. Area for polar curves, that was the formula which we initially proved, and how to find out the area of a polar curve or polar equation of a curve under the polar equation. Okay, that is the question. Now let me take question number 9. Ninth question is question number 9 here. It says find the area of the cardioid. Okay, where cardioid is, the cardioid here, r is equal to a into 1 plus cos theta. Okay, so this is symmetric about the initial line, because theta, if I replace by minus theta, the curve will be symmetric about the initial line. Solution. Let me find out the solution of this. The solution. The first point is this curve is, the curve is symmetric about the initial line. Okay, initial line. Why? As theta replaced by minus theta doesn't change the curve. Okay, so because of that, this is symmetric about initial line. Let me draw the curve, but before drawing the curve, let me just take this is the initial line, OX here. Okay, so this is symmetric about initial line. What are the point if I put r equal to 0? Putting r equal to 0, where cos theta is equal to minus 1. That means when it is minus 1 here, it is equal to cos 0, because this is cos minus 1 here, so it is 0, because cos, sorry, minus pi, I'm sorry, this is pi here, because minus 1 is for pi, so theta equal to pi here. At r equal to 0, cos is pi, sorry, theta is pi here. R equal to 0, theta is pi, 0 here, and so this is pi here, theta equal to pi in this case. That means we have to start this curve from here. Okay, this is the curve. Theta r is equal to 0 and theta is equal to pi. Okay, and at this point, when we put r equal to theta equal to pi, then it will be minus 1, so it is 0. In that case, it is when theta equal to, sorry, from this theta has come out as pi, that it is minus 1, so when r is 0 here. Okay, so theta, at theta equal to 0, it is 2a. At theta equal to 0 here, theta equal to 0, this is twice a. This length is twice a here. This is theta 0, r is equal to twice a. Okay, this is twice a r and theta is 0. This is the point here. So what is the curve? Let me take the strip here. This is PQ. Okay, this is delta theta, and this is theta. If I take, we can find out the area of this curve is, but here limits are from 0 to pi. Limits we will take 0 to pi. Okay, and the area is twice of this upper area. Let me take, this is A point, this is B point, this is O here. So area, required area, let me take. So required area is equal to 2 times area OAB. Twice of area OAB means this OAB area, upper portion of this curve, and then the lower portion is added. So twice of this area of upper. That means this is twice into area of OAB. If I put this is 1.2, we know limits 0 to pi. Okay, r square into d theta. This formula we know about, but here limits are only 0 to pi. This 2 to cancel out. This is 0 to pi. R square here is this. This is a square into 1 plus cos theta whole square into d theta. So this is equal to a square. If I take out of the sign of integration, this is 0 to pi. Let me open this. This is 1 plus 2 cos theta plus cos square theta into d theta. Finally, we have to integrate this. Okay, so let me integrate this. So this will give us the final answer. What is that answer here? Total area. Total area or required area is equal to a square. Let me write 0 to pi here first. 2 cos theta. Let me write the same question here. Not, still not integrated. Okay, so this will give us a square into 1 integration is theta plus 2 cos theta is 2 sin theta. Okay, plus now cos square theta. If I write, then I have to write here 0 to pi by 2, and this is cos square theta. No change. The reason is what we have done. Let me write here limit 0 to pi. If we apply this 0 to pi limits for this, these two, and this equation is now a square is multiplied to the whole. Okay, so let me write here. Question will give us, this is a square and theta. If I put the upper limit, this is pi at 0 to 0, and but at 2 sin theta at pi and 0, both will be 0. That is plus 0, nothing else. Plus this value 2 into, why I put that twice? Well, limit was 0 to pi. I put twice, and 0 to pi by 2 we can make Okay, so this is cos square theta. Cos square theta then value is by reduction formula 1.2 into pi by 2. This 2 cancelled out. Okay, so finally we can solve it. This is a square within bracket pi plus pi by 2. So this is 3 pi by 2. That means 3 pi a square upon 2. So this is the final answer. 3 pi a square, because this is 3 pi by 2 and into a square, so 3 pi by 2 a square. This is the final answer. Question number 9. Question number 9 is done, or 9th question is done here. So this was the cardioid, okay, of this shape. Question number 9th. And question 2nd, we did a similar type of question, but it was 1 minus cos theta. A into 1 minus cos theta. That was of this kind of curve. This started from this point. Because that was the cardioid. Because in 17th question, the two have been combined. It said find the area of the portion included between the cardioids are equal to A into 1 plus cos theta and are equal to A into 1 minus cos theta. So the second question and 9th question both are combined in 17th question. That is, we will find out. That is also very interesting question. We'll discuss about that. So this is the question 9. Okay, 9th question we have done. Answer here is this. Okay, 3 pi by 2 into a square. Question number 9 is done. 9th question done. So let me take now 10th question. Or question number 10. What does it say? Let me check it out. Question 10 is show that the area of a loop. Okay, so this is R is equal to A into cos n theta. Alright. Cos n theta. It says so that the area of a loop of R equal to A cos n theta, yeah, is pi into a square upon 4n. Okay, n being integer, n being an integer, and also prove that, and also to prove that the area is, the whole area is 1.4 pi a square or 1.2 pi a square if, or according as n is odd or even. Okay, n is odd or even means what? If n is odd number, then area is this 1.4 pi a square, and if n is even, then it is 1.4 pi a square. This we have to prove here. All right. First, let me prove that this is the area. Now, in this case, if I put n, multiply this by n, and n cancel out. This is pi a square upon 4 is the first, because if n is odd number, the number of loops will be n only, because odd number is having the same number. So if I multiply this area by n, because we have to multiply by number of loops. How many loops are there? If there are 2 loops, we have to multiply by the area by 2. Okay, if it is n times, twice n, even number, so twice n multiplied, this will be n and 2. So this is pi a square upon 2. This is the second answer. First, we have to prove that this is the area of this curve. Okay, so let me find out first this answer. Okay, so this area. Okay, so this is cardioid here again. This is okay. This kind of question we proved in. We proved in which one? It can be taken from not in the 9th one. Still we are not proof this kind of question. No problem at all. Okay. Let me take this question first. So solution. Now because here n is unknown number, so it can have number of loops according to the point. If it is an odd number, then n number of, okay, suppose n is 3, then 3 is odd number, so then 3 loops are there. If n is even number, suppose 2 is there, then there will be 4 loops. In this way, n is odd number, even number, but before that let me solve it. If I put, now if theta is odd number, let me take solution. First point, if theta is replaced by minus theta, the curve, because it is cos theta is an even number, so minus sign doesn't change it. Okay, so minus theta, if I replace theta by minus theta, then the curve remains unchanged. Then curve remains unchanged. That means this curve is symmetric. This curve is symmetric about initial line. It is symmetric about initial line. Okay, so whatever number of curves are there, they will be symmetric to the initial line. But above initial line and below initial line, the shape of the curves will be same. The number of loops will be same. That way we can imagine about. Second point, putting r equal to theta. Putting r equal to theta here. Putting r equal to theta. So what is the, sorry, r equal to 0. What I am putting? Putting r equal to 0 answer. So we get a cos n theta equal to 0 or cos n theta equal to 0. 0 is for cos pi by 2. Because cos pi by 2 is 0. It means n theta is equal to plus minus negative value is also, because minus pi by 2 is also 0. It is plus minus pi by 2. That means theta is equal to plus minus pi upon twice n. So limits are from pi upon twice n to positive pi upon minus pi upon twice n to this. So limits we will take. Therefore, the area or required area, let me take. The required area of the curve given will be equal to 1.2 into limits. This is minus pi upon n, that is minus pi upon twice n 2. Okay, to positive pi upon twice n. Let me write it here. This is minus pi upon 2n to positive pi upon 2n into r square into d theta. This can be written as twice of this. This is twice into 1.2, limits 0 to now pi upon 2n. This is fourth property of definite integrals we know about. Okay, this is one of the property of definite integrals, that the limits are minus a to plus a, then limits become 0 to a, and twice we have to multiply. Multiplying by 2 into this integral, we have got this 2 to cancel out, and this is 0 to now pi upon twice and limits. And r square is this. This is nothing but a square into cos square n theta. Cos square n theta into d theta. Okay. Now, if I put n theta equal to something, let me put here. So, putting limits, let me change. Putting n theta is equal to, let me take 5. That means d theta will be equal to d phi upon n, one thing, and limits will be what? At phi upon twice n, if I put theta equal to phi equal to n theta, when theta is pi upon twice n, at limits at theta is equal to phi upon twice n, the upper limit, so phi will be equal to n into pi upon 2n, that means n cancel out, it is pi upon 2, upper limit is pi upon 2, lower limit is 0, so at 0 it is 0, so from 0 to pi by 2, now limits are changed, so phi equal to pi by 2 upper limit, and at theta equal to 0, phi equal to 0. So limits are, now let me put, this is a square outside required area, limits 0 to, and now this is upon n here because d phi upon n is coming, n I have taken outside, 0 to pi by 2, this is cos square, and theta we have taken phi into d phi, this is nothing but a square upon n, a square upon n into, now this is reduction formula we can apply. So reduction formula for cos square for 2 it is 1.2 into pi by 2. Applying the reduction formula, let me write here. Applying a reduction formula for sine. Applying a reduction formula. Okay, or by reduction formula, this we have obtained. This is nothing but pi a square upon 4n. This is the answer we have proved. This area of this curve will be pi a square upon 4n. Now, the other two answers let me prove. Okay, this is the first answer has been proved, that this is the area pi a square upon 4n, which we have proved here of that curve given. Now, if it says now, if n is an odd number, then number of loops